All right, so I'm going to give you a mini lesson on functional groups, try to just give you the basics. So we've talked about organic molecules, and they're just these long chains of C's, and then they have these, those are supposed to be H's. They have these H's around them to kind of fill in, just make sure every C has 4 bonds. It's kind of what the H's are for. Sometimes there's like a double bond in there or something. But like right now, this is just like kind of an oil. It's just an alkane. Different kinds of oil. It could be butane or propane or octane. This happens to be 4, so it's butane. Now we're going to give it a function just by adding a little group. So we call this functional groups. They're little groups you can stick on the end to give that organic molecule a function. So, there's my dog. If you stick an OH on the end, so if I take this butane, I stick an OH on the end, now it's an alcohol, okay? Because alcohols are just organic molecules with an OH on the end. All right, so I'm going to do this whole lesson for you just looking at this table R, because literally everything you need to know about organic functional groups is just all on this table. So they are groups that give function. Like if you add an OH group, now you function like an alcohol. Same thing. If I stuck on the last C, if I stuck an OH and then a double bonded O, so if I make this a double bonded O instead, now I've turned this butane into butanic acid. Before the alcohol was butanol instead of butane. So again, I'm just putting on these little groups that give function, and that's what I'm going to show you today. All right, so our first functional group are halides or halocarbons, and they are when you add any halogen to an organic compound. And you don't have to remember what those halogens are because it says right here. So if you stick a fluorine, a chlorine, a bromine, or an iodine onto an organic molecule, now you have turned it into, that would be turning this, this is propane, I'd be turning it into now fluoropropane, all right? And that's now, pretend that these are H's. Remember, instead of writing all these H's because it's annoying, you can just leave it as lines and it's just like assumed that there's an H there. So if I just take a regular old organic molecule, stick any of these 4 on there, I've now made it a halocarbon because it's a carbon chain with a halogen stuck to it. How do you name this? Well, look at the name of this one. They always give an example, and that usually helps. So this one they call 2-chloropropane. So what do you think that might be? Oops, I didn't press the pause button. I thought I did. Okay, so 2-chloropropane is probably propane with a chlorine off of the 2 carbon, and it is. Okay, so if we were in class, I would have taught you all about how to name halogens and draw them, but you can really get a lot out of just this right here. You go, okay, a halide has any halogen any of those stuck to it. The general formula is just the R just means like the organic molecule, and then it has an X stuck on it, and the X is a halogen. That's not really that helpful. And then the name is 2-chloropropane. So you're like, oh, that's how you name them. You write propane, you put a chloro in front of it, and then you put a number to say where it is. All right, so a lot you can figure out from the functional group. All right, so on to alcohols. Everyone always loves talking about alcohol, right? It's what people can drink. So you're like, okay, what's an alcohol? I forget. You go to table R and you're like, oh yeah, it's anything with an OH stuck to the end. So remember when we were in acids and bases and I said, don't get your bases mixed up with your alcohols. So I'll just give you a quick reminder. Alcohol is an organic compound, so it's really like any CH chain with an OH stuck to the end. Base is like any metal with an OH stuck to the end. All right, so alcohol is organic, so it's this long chain of C's and H's with an OH on the end. Base is just like any metal with an OH stuck on the end. Okay, so then you're like, what else can I learn about alcohol? This is just this is what we call a condensed formula. So it's like CH3, so it's like instead of drawing a C with 3 H's, and then the next one says CH2, then a C with 2 H's, And then the next one is a C with an H. So it's just like instead of drawing the whole thing out, they just made it this little condensed formula. But instead of just saying, okay, there's 6 C's, 12 H's, 6 O's, they want to at least give you more information than that. So they say, okay, first there's a C with 3 H's, then a C with 2 H's, then a C with an H, then an OH. So it's called a condensed structural formula. Again, if we were in school, I would teach you all about how to do them, but you just have to kind of have the general idea. Okay, so what else can I tell about alcohol? So I'm going to know I'm looking at an alcohol because it's just an organic compound, C's and H's with an OH stuck on the end. And then let's look at how they name alcohols. So it looks like this alcohol is called propanol. So I'm kind of like, oh, propan, I think that's 3 C's. And then it looks like all you do to name an alcohol is just take the propane name, chop off the E, and add an all ending. So again, if we were in school, we would have learned how to name alcohols, but you can kind of just look at table R and go, okay, how do you name alcohols? Oh, looks like all they do is chop off the E and write all. So what is this? Propanol. So it's propane, 3 C's, all single bonds. And then instead of just all H's, because it's an alcohol, I'm like, okay, what makes it an alcohol? Okay, an OH on the end. And then the 1 means it's off the first carbon, so I can put it off either first carbon. All right, so there is my alcohol. All right, so what does table R tell us about alcohols? They end in OH, and when you're naming them, you just change, not they end in OH, they have an OH stuck to them. And then when you're naming them, you put an all at the end. And then again, what do we use alcohol for? It is in drinks, right? And also, from hand sanitizer. Remember, certain hand sanitizers, to kill coronavirus, has to have a certain percentage alcohol. Right, so that's alcohol. All right, so on to ether. Even if you have no idea what an ether is, you can just go, okay, that's an ether. Well, an ether looks like it has this O with lines either way. What does that mean? All right, so I look at the general formula and it's like O with lines either way. If I look at the condensed formula, it's like C with 3 H's and then an O, then a C with 2 H's. So it's not like the last ones where the OH was stuck on the end. It looks like from these pictures, an ether has an O in the middle of the chain. That's why they drew it like this, to show you that it's like an O with stuff on either side. All right, so if I look at the name, you don't have to know how to do this, but it's methyl ethyl ether. So that means that it's a methyl, 1 C, and then the O, and then the ethyl, that's 2 C's on the other side, and there is your methyl ethyl ether. Isn't that a fun name? All right, so if you take it in college, you have to learn how to name that. But for now, if you need to know what an ether is, just go look. Okay, ether has an O in the middle of its carbon chain, and looks like they name it by naming 2 little groups, and then they put the word ether at the end. So if I need to know if I'm reading something, how do I know if it's an ether? Well, it'll have ether at the end. So that makes it kind of easy. All right, next is aldehydes. So aldehyde, it has a C with a double bonded O and an H. All right, so C with a double bonded O and an H. So I can see it in these 3 different places. That's what an aldehyde is. So if they give me a bunch of molecules and they say which is an aldehyde, I'm going to be looking for this. What about the name? Propanol. Propanol. Looks like all they did was take propane, chop off the E, and put al. All right, so if you need to know, if they give you a bunch of words, like here's butane, butanal, butanol, which one's the aldehyde, you'd go, okay, well, it looks like aldehydes end in al. All right, so you can memorize that aldehyde ends in al, or you can just go to this table and see that aldehydes end in al. Propanol, what does that mean? It means it's propane means 3 C's, and propanol means it has this double O and an H on the end, and then I would just fill in the rest of my C's with H's so that every C has 4 bonds altogether. Notice I didn't put one here because this C already has 1, 2, 3, 4 bonds. So if you do take this in college, when you're drawing, you have to make sure, and that would be something we would practice in school, but we're not going to. You have to make sure that you never you assign H's so that every C gets exactly 4 bonds, no more and no less. Okay, down to ketones. So I'm like ketones, C-double-O. Okay, how is this any different than the last one? So what about this picture is different? It's got that C-double-O. How is it different? Okay, well, there's no H. And it's also got these lines coming off of it, or like R groups in either direction. It's trying to tell you that that double O is now in the middle. So it's a C-double-O, just like an aldehyde, but it's a C-double-O for aldehyde was at the end of a chain. C-double-O for ketones are in the middle of a chain. So the way I always remember that is like aldehyde, like your hide is like your butt, so it's like near it's like your rear end. So aldehydes are on your hide, they're on your end. And ketones, like a key goes into like the middle of a lock. So ketones, that C-double-O is always in the middle. But again, you don't have to memorize it because it shows in the picture. Okay, here the double O is in the middle. Here the double O is on the end because they kind of show like the little line. All right, so I'm going to know I'm looking at a ketone if I see a double bonded O to a C in the middle of a chain. What about the name? How am I going to look at something and go, oh, I bet that's a ketone. Let's look at the name. 2-pentanone. Okay, it looks like ketones just end in "-one". Looks like they took pentane, dropped the E, and changed it to pentanone. They also put a 2 out in front. So if I try to draw that, I could go, okay, pentanone. So I always start with like the main part. And again, we would spend like a week learning to draw these. But pentanone, okay, so that's pentane, pentan, 5 C's, and then "-one" means I need to put a double O in the middle of the chain. But what's the middle of this chain? These are all middle of the chain. Doesn't mean like dead center. Where do I put it? Which carbon do I put it off? Oh, there's a 2 here. So 2-pentanone means put that double bonded O off of the second carbon. Yes, honey. All right. And then to finish the molecule, I'll just go through and I'll put H's all around the C's. It's supposed to be, oh no, not what I meant to do. No. Pause. Sorry, we were drawing pentanone. It's 2-pentanone, so the double bonded O is off of the 2, the second carbon, and then I'm going to go through and give each C enough H's. So now this C has 1, 2, 3, 4 bonds. This C has 1, 2, 3, 4. So I am not going to put an H there. Sorry, it's so sloppy. This C has 1, 2, so I'll give it 3, 4. So it's kind of like there's all these little spaces around it to fill. But if there's a double bond, that usually means like, okay, now there's another bond taken up, so you're going to end up with like an empty space. This C has 1, 2 bonds. C's like to have 4, so I'll give that 2 H's. And then this C at the end only has this 1 bond, so usually C's at the end end up with 3 H's. So a lot of things end in CH3. So again, what do we know about ketones? Well, they're very similar to aldehydes. They have that C-double-O, but aldehydes are showing them at the end of the chain. Ketones are showing them with these 2 lines to show that they're in the middle of a chain. How do you name them? Aldehydes end in "-al", ketones end in "-one". Isn't that nice? Okay, on to organic acids. We have talked about organic acids. This is an organic acid, meaning it's going to be like a long chain of C's because that's what makes something organic, just lots of C's. And okay, so I just look at the picture. I'm like, all right, tell me everything I need to know about organic acids. Well, it looks like it's got another C bonded to a double bonded to an O. So I just always say C-double-O. How am I supposed to tell that apart from aldehydes and ketones? Okay, well, it's got a C-double-O, but it's also got an OH. Okay, so that's how I'm going to tell an organic acid. So again, you don't have to memorize that. You can just be like, all right, what am I looking at? Who's got C-double-O-OH on the end? Okay, organic acid. How do I tell ketones from organic acids? Okay, ketones have a double bonded O, but organic acids have a double bonded O and an OH. Okay, so organic acids have C-double-O and OH. Let me look at the name. Propanoic acid. Looks like they just took the word propane and chopped off the E, so propane. And they said, we'll just drop the E. And just like for alcohol, they added like all to make it propanol. They'll drop this E and just add oic acid. Right? So if you ever need to name an acid, or if you're just reading a label, you'll know if it's like propanoic acid that it's an organic acid. But you'll know if it says like pentanone that it's a ketone. Okay, so how do we draw it? Propanoic acid tells me, okay, propane, that's 3 C's all, and it's, remember, alkane, it's all single bonded. So propane, and then to make it propanoic acid, I need to add the acid part. So all these pictures show me what the acid part looks like. It looks like there's a double O and an OH. All right, so I did propane. I added the acid part to make it propanoic acid. And now I'm just going to, once I have everything they told me to put, I'm just going to add enough H's so that everybody's got 4 bonds. So this C, this is where people usually mess up. This C already has 1, 2, 3, 4 bonds. So I will not put an H there. So usually when there's a double bond, you end up with like this blank space where there's no bond. Okay, on to esters. So I just look at the picture of an ester, either one, really any of them will do. I think these 2 are easier. And I'm like, oh, another C bonded, double bonded to an O. All right, how am I going to tell this apart? Okay, then it's bonded to an O. Well, so is this. These lines right here are showing, again, lines in either direction, that this is in the middle of a chain. All right, so esters have C double O, and these little R groups mean like it continues either direction, so it's like in a chain. All right. So if I were to name it, even if like you can't name it yourself and you can't draw it yourself, just knowing that if you see something with this naming structure, like methylpropanoate, just knowing that like esters end in O8, you could look at a bottle of chemicals and look at this chart and go, okay, that's an ester. So it's probably going to have a nice smell. Esters usually have nice smells. So ester always reminds me of like a grandma's name. And grandmas smell good, right? An old lady name, old lady smell good? Maybe not. Okay, so methylpropanoate, propane, again, means 3 C's. Methylpropanoate. So I'm supposed to put this C double O thing in the middle of a chain. So the methyl tells me that, like, there's another C over here, and then that little, like, where is it? O thing is there. All right, so that is an ester. It's got the C double O in the middle of a chain. Oops, sorry. I should have put this here so that it's in the middle of the chain. And there would be like a little bond right there. Sorry, it's hard to draw. Okay. Okay, on to amines. Let's see. Oh, good. No more of those double O's. We had a whole bunch of double O's in the middle. So again, these are going to be annoying. You need to look carefully, but you don't need to memorize. You just need to look at this chart. Amines look like they just have an N with lines in 3 directions. So it looks like it's an N. It kind of seems like it means in the middle of a chain. Although here you can see it's really not. But it says, let's look at the naming. Okay, so if I see an N in a chain, I'm going to call it an amine. And if you remember amino acids from biology, amino acids, you could always tell because they had an N in them. Amino acids make up protein. Amine, protein, have N in them. They all have N in them. So amino acids and protein all have nitrogen in them. And that's kind of why like you have to eat protein because it's like where you get your nitrogen from. Anyways, so propanamine. So I'm like, okay, if I see something ending in amine, I can be like, okay, that's an amine. Okay, so the organic names are really nice. They're pretty simple. Like if it ends in amine, it's amine. If it ends in one, it's a ketone. So they're kind of nice that way. But let me see if I can figure out just from the name like what it is. Propanamine. So propane. Looks like somebody took the name propane, which is an alkane with 3. So that's 3 C's. So you feel really smart once you're able to do this because you're like, oh, propanamine, let me draw that. So you're like, oh, propane, that means 3 C's. The fact that it's an and not like een or ein means they're all single bonded, which they usually will be in this. And then, so I got the propane part. And then amine. So I got to add this. So then I'm like, all right, what does it mean to be an amine? It means you have an N. And like, where do I put it? It says off of the 1 carbon. So I'll just like stick an N off the 1 carbon. I could have put it up. I could have put it to the side. Doesn't matter. And then then I can just fill in with H's. Once I've done everything that they've like told me to, basically you just fill in with H's. So I don't think I showed you this that much, but so I'll show you again. So this C already has 1, 2, 3, 4. Oh, well, these are supposed to be H's. All right, so it already had these two, so I added these two. This is not a double bond. That's supposed to be single. All right, this C has 1, 2, so I'll give it 3, 4. It's supposed to be an H. So bad. This C just has 1, so it needs 3 more because all C's like to have 4 bonds. So a lot of times the N's have 3 H's. All right, this one's done. And then this N's actually like to have 3 bonds, which you can actually kind of tell from that picture. So I'm going to give them 3 H's. Okay. Oops, but the N likes to have 3 bonds and it already had 1, so it only wanted 2 more. So there we go. Now it's right. Okay, last one is amide. That sounds a lot like amine. Oh, and it also has N in it, but it looks more annoying. So it looks like it's got an NH bonded to a C, which is bonded to a double O. So again, if you see an N in something, you know it's either an amine or an amide, but you can look at this chart and go, okay, if it's like just an N is the only weird thing on my chain of C's, that's amine. But if it's like an N bonded to a C that's double bonded to an O, that's an amide. All right, so that's how you're going to recognize an amide. What if you see a name? How are you going to know that that's an amide? Because it ends in amide, okay? So that's kind of nice, right? Move myself up there. What if I was trying to draw propanamide? Could I do that? Oh my God, I'm so smart. Okay, so propane looks like propanamide. All they did was drop the E. A lot of times they drop the E. That's most naming. And I made propane into propanamide. So let me draw. Okay, so propane. Prop means 3 C's. Ane means all single bonds. Check, check. All right, amide. So what does amide mean? Oh, it means there's an N and a C with a double bonded O. There's no number to tell me where it is, so I'm just going to assume it's on one of the ends. So I could pick either end to put it on. I'm just kind of used to putting things like on the end over here. So it looks like, and I can even use this picture, it looks like they go kind of up with the double O, bonded O, and then to the right with the N. I could even look, oh, they have 2 H's. All right, so last time I'm just going to show you how to do H's. You would have to do this on your own. So I just go through and I make sure everybody's got the number of bonds they want. If they don't, I'm going to fill it in with H's. So this N has 1 bond. N is in group 15, so it's 5 valence electrons, so it wants 3 more. If it wants 3 more, then it wants 3 bonds. So right now it has 1 bond, so I'm going to give it 2 more. However many more electrons you need is how many bonds you like to form. All right, this C has 1, 2, 3, 4. Okay, so this C is good. Don't give it any H's. If I put this H, the whole thing would be ruined. This C has 1, 2, so I'll give it 3, 4. This C just has the 1, so it needs 3 more to get to 4 bonds. So a lot of times C's in the end have 3 H's. All right, so that is organic functional groups. It's you literally just take some chain of C's. A lot of these were propane, but it could be pentane. It could be any chain of C's. And you stick one of these little groups on, and it turns it into one of these different types of organic molecules. And with that, we have like a gazillion organic molecules in our world. Esters that smell good, alcohols that can be used for cleaning or getting you drunk. Amino acids that make up the proteins. So just by putting these little variations onto long chains, we get a whole bunch of molecules to make up our world.